Right, here's a quick walk around of the electric bike. Show how it works and the things that it needs. First thing it's going to need is a rear rim. It's got a pretty decent dent there. I think that's going to be repaired. Another thing, the little nut came off of this switch. I lost it somewhere. It used to have one of the red covers on it. And last night the wind knocked it over and broke the tang off the throttle. It's still rideable. It actually works pretty well. That's how you push the throttle. And it allows you to maintain your 3 fingers and thumb on the bike, so you can hold on what you need to do. It's got a 3-speed switch on it that's not hooked up to anything. That was for the old Infineon controller. And got a bell for safety. And here's the NuVinci controller. This is your easier gears. Those are your harder gears. It's got the Avid Elixir brakes on the front and the RockShox U-turn coil fork with 4 to 5 inches of adjustable travel, and it's got a lockout. Back in the back we've got the Surly chain tensioner and the NuVinci hub. Got demolition sealed pedals and an older XTR crankset with an MRP bash guard. It's not pretty, but it's really functional and light. Got standard rim brakes in the back and an Adamo Typhoon ergonomic saddle. Up front here we have the demolition stem and the old snowmobile handlebars, which are actually very comfortable. Let's see if I can bring them up here. Back here we've got the 219 O-ring chain on the sprocket that's bolted to the disc brake mount of the NuVinci. This piece acts as a chain guard and a frame stabilizer. It keeps the reduction drive mounts from twisting on the frame and keeps the chain stays from spreading out under the chain torque. To adjust the chain tension, you can either use these bolts here, and you have to pivot the motor down sometimes if you need to go further, or you can move this tensioner back to put more tension on it. When you remove the wheel, you loosen this bolt, the tensioner will pivot out of the way. That puts the slack out of the chain, and then you can take it off. You can see the sprocket has very little to no wear, and this is after roughly 2,000 miles. There's another shot of the crank on the other side. It's not beautiful, but totally functional. There's the Castle Creations Phoenix Ice HV160 revision 2, totally unmodified, no extra caps or anything. It's worked flawlessly. I can't see any reason to modify it. So let's open her up. High-tech duct tape attachment system here. Has to be peeled off and replaced ever so often. So let's look at this side. On this side we have 3 of the Turnigy 6S 5 amp hour batteries. These are the Gary Goodrum LVC HVC boards. I do not have these interfaced to the throttle at the time. That's something that will need to be done. One wire will tie to ground of these here, and the other one will tie to the throttle, so it'll ground the throttle if a cell sees 3.15. I've got the low voltage cutout set at 40 volts on the Cycle Analyst, and I've got it set, I think it's 38 volts on the Castle Creations HV160. It'll also come with the Castle Link tuner, so you can hook it to your computer. This shows the parallel blocks that I made The Turnigy batteries simply plug into these, and then it's got 100 amp shunt here, and that's what the cycle analysts use to measure current. This shows the recumbence reduction drive. The belt's in really good shape. It's a 1/2 inch shaft on the Astro 3220, and I shaved off the silver clutch here for clearance, and so it doesn't catch on ankles and stuff like that. I still recommend not wearing pants, or getting the pant leg out of the way, because it does have a tendency to get caught in that if you have long pants on. The battery mount is all made out of 1/4 inch plywood. These little blocks pop into place and locate the batteries pretty well. Actually, that one's a little loose. And then the side cover is not too high tech. Like I said, it's cardboard and plastic, and it does a good job of keeping the batteries in place, and it's not metal, so it can't short them out if there's a problem. So let's go to the other side. And the other side shows the other low voltage, high voltage board. And like I said, the Turnigy batteries just cover in here. And here's the connector that will need to be interfaced to the throttle. Just something that I haven't done yet. It's a pretty simple thing, and there are quite a few instructions on Endless Sphere. 3 more Turnigy 5.0 6S batteries on this side. It's wired for 15 amp hour, 44 volt nominal. In here is a CSK25 one-way bearing, and also inside of the 10-tooth sprocket is a 3/4 inch roller clutch, and between both of those it provides freewheeling action with no clicking. There's the Astro 3220 4-turn, and I've gone ahead and brought all of the phase wires out, so if you want to experiment with delta Y termination and stuff like that, that's possible. This plug plugs into the harness for the Hyperion 1420 charger. It just simply plugs in, and the charger is all set up to charge and balance the batteries all at the same time. I used to have a pre-charge resistor wired on here, but it came off the harness in one of my rides, and so I haven't reconnected it. It doesn't seem to be a big issue. I'm using 2 4mm bullets for the main power connection, and under testing, these vaporize at about 300 amps, so they work as a good fuse, and they also seem to transmit the power pretty well. This is where the power for the ignition is tied in. So let's connect it. It's going to spark a little, and you hear the Castle Creations controller waking up and looking for its throttle signal. So the next step is to go up here and turn on the power switch. You'll see the cycle analyst light up, and the Castle Creations controller will give its tone to signal that it's got throttle. Let me go ahead and tape the enclosure back together. Okay, now we got her all taped up. The next step to do is to help the motor find sync. And what I do is I lift the seat up to get the rear wheel off the ground. And then I'll turn the pedals so the bike goes over 4 miles an hour. And that'll engage the throttle. The next step is to use the rear brake to stop it. And now the motor is synced up, and next time I hit the throttle, once it's going over 3 miles an hour, the throttle will come in very smoothly and predictably. I've also got the low voltage threshold for the throttle set on the cycle analyst, so it's slightly above the resting voltage of the throttle. So when you're coasting along, the motor is always spinning, so it's not back driving the chain. It makes it quieter, and it also makes it a lot smoother when the throttle engages. So let's do a quick demonstration ride. Hopefully this works here. Over, no barking. Oh.